First, trench cutters slice a 3-foot thick channel to create a circle 260 feet across. Workers fill the channel with concrete, creating a huge containing wall, and sink 137 concrete columns, known as piles, 200 feet down into the ground, packed as close together as possible for maximum support. Next, diggers excavate down to reveal the piles, and ironworkers stitch them together with 300 miles of steel rebar. Then cover it with 45,000 tons of concrete. When dry, this ultra-strong foundation should support the vast tower above with ease. To cast a single level of a core, workers build a mold from wooden panels and fill it with concrete. Traditionally, they would then remove the panels, build new scaffolding, and lift the molds back up. But for a building this tall, that would take years too long. Instead, steel rails bolted to the core support a giant movable platform that carries the mold sections as it climbs the rails. Workers lock the mold's wooden panels together when pouring concrete and release them once the concrete is set. Then, hydraulics push the platform upwards, effortlessly transporting the molds and equipment up the tower to repeat the process. This clever system means the team can power upwards, adding each new level in as little as 5 days. The core and the mega columns have only the thin floor levels to connect them and could start to move independently. To secure them, engineers insert giant pieces of steel into the concrete columns at 3 key levels up the tower. They connect them to the core with enormous diagonal arms called outriggers. These tie the columns and the core together, allowing them to support each other and move as one. For extra stability, engineers encircle the same levels with huge steel trusses that grip the tower like a series of belts, making it strong enough to extend high into the clouds. The skyscraper's cranes are attached to its concrete core with 2 giant steel brackets. But as crews build the core higher and higher, the cranes have to move up. Otherwise, they'll impede progress. First, engineers install a 3rd bracket higher up the tower that supports a pair of narrow metal ladders. With these in place, engineers move the crane's metal feet onto this super strong ladder. A hydraulic press raises the crane up. When it reaches the rung above, a 2nd set of feet catch onto the ladder. The hydraulic piston resets and pushes off again. By climbing up each 2-foot-high rung at a time, the cranes stay ahead of the crews below. This 120,000-pound block of precisely engineered steel is the most important part of the tower's vast atrium. The team must lift the node at exactly the right angle so it fits onto its supports perfectly. To do that, they use 2 cranes, one to hold the bottom end clear of the ground, and the other larger crane to rotate it. Once it is at the right angle, the main crane lifts it up the tower, and the workers on the atrium's colossal steel beams carefully guide the node into position. They must get the placement of this behemoth perfect, because it alone will hold the entire 42-story atrium together.